Yo, welcome back. Today's lesson is lesson 18, subtraction in equivalent expressions in your workbook. It says, let us find ways to work with subtraction in expressions. So basically, when we're talking about subtraction in expressions, we're talking about adding the opposite. So if I had like x minus 3, that would be the same thing as x plus a negative 3. And you can write that in your book. But that's the main idea. Okay. So next section says number talk additive inverses. Find each sum or difference mentally. Okay, so if we did negative 30 plus negative 10, that would give us a negative 40. All right, negative 40, and that's kind of like if we were on a number line like this. I wish I could draw straight lines with this pen. And then we went over here and started at negative 30. And then I added negative 10. That would bring me over here to negative 40. So this would be starting at negative 30 and plus a negative 10. All right, so anyway, going on to the next one, a negative 10 plus negative 30. That's the similar. Okay, but we're just reversing it. Instead of starting at negative 30, we're starting at negative 10. So you're going to get another negative 40 right there. All right, so with this one, we have a negative 30 minus 10. That is going to be a negative 30 plus, and it's like keep change. I think that's how you all recall that. And then that's going to be a negative 10. So you're going to keep the negative 30, change the subtract to add, and then change the 10 to a negative 10. And we're going to get again a negative 40. Next one, we got 10 minus negative 30. That is going to be changed to a plus, and then change this one from a negative to a positive. So that's going to be keep change, if that helps you remember. So that would be a 10 plus, it was negative 30, now it's going to be a positive 30. So then that's going to give you a 40. So we got 3 negative 40s and 1 positive 40. All right, let's go on to the next section. All right, let's go down to the next section. All right, let's go on to the next section, 18.2, a helpful observation. It's a lot reading right here. Okay, Lynn and Karen are trying to calculate 7 3/4 plus 3 5/6 minus 1 3/4. Here's their conversation. Lynn, I plan to first add 7 3/4 and 3 5/6. So I will have to start by finding equivalent fractions with a common denominator. Okay, you could do that. She says she's going to start by doing this section first. Okay, but that's a lot of work finding the common denominators. Karen, it would be a lot easier if you could start by working with the 1 3/4 since they have the same fraction, same denominator. Can we rewrite it like 7 3/4 plus 1 3/4? So basically she switched these numbers. Okay, now it does make sense to try to match up the matching fractions with the same denominator. She says you can't switch the order of the numbers in a subtraction problem like you can with addition. 2 minus 3 is not equal to 3 minus 2. That's an excellent point. Karen, that's true, but do you remember that what we learned about rewriting subtraction expressions using addition? 2 minus 3 is equal to 2 plus negative 3. Okay, so that's what we were talking about again, about when you subtraction the same as adding the opposite. So all those are valid points. Okay, so then it says write an expression that is equivalent to 7 and 3/4 plus 3 and 5/6 minus 1 and 3/4 that uses addition instead of subtraction. All right. All right, so let's see how this goes. Write an expression that is equivalent to 7 and 3/4. Okay, so we're going to write an equivalent expression. So we got 7 and 3/4 plus, okay, 3 and 5/6. And we have a subtraction here. So we're going to do like keep, change, and change. So that would be keep the 3 and 5/6, change the minus to plus, and now we have to change 1 and 3/4 into negative 1 and 3/4. Okay, so now that we have all addition, okay, so this has been converted to a complete addition problem. Now we can change the order. Okay, so it says if you wrote the terms of your new expression in a different order, would it still be equivalent? Explain your reasoning. So if we did 7 and 3/4, and then we can now move this over here, and we got plus negative 1 and 3/4. And then now we can move this one over here, and we have plus 3 and 5/6. All right, and that makes sense. Now that makes sense because now we have the same denominators matched up. So if we're doing a 7 and 3/4 minus plus a negative 1 and 3/4, that's going to equal the 3/4 plus a negative 3/4 is 0, and a positive 7 plus a negative 1 is going to give you a 6. Okay, so this right here is going to equal 6 plus 3 and 5/6, and then the 6 plus 3 is going to give us a 9 and 5/6. So that becomes, just by using a little strategy and thinking, you'd make a what would be a complex problem into a simple problem. So that is a good point. If you just use a little bit of strategy, you can make a difficult problem a lot easier to manage. All right, so that's what I got from that problem, along with the other information about the plus and the minus. All right, let's go on to the next section. Boom. Boom, boom, boom. All right, next section says organizing work. Write 2 expressions for the area of the big rectangle. All right, so when you're using these area models or tape models, okay, so for example, if you had a tape model like this, boom. All right, that is just, I could do, boom, let me do this again, tape model, boom. All right, so we got this tape model like this, and then it's not going to be large enough, boom, Work with me. All right, boom. Tape model, and then I got 2, and this is 5, and this is 3. All right. So we can look at that as 2 times 5. So in here would be 2 times 5, and in here would be 2 times 3. And then if we wrote that as an expression, we would have first the area equals 2 times 5 plus 2 times 3. All right. But it could also be an equivalent expression, which is 2. We could combine these right here. Okay. 5 plus 3, and it could be 2 times 5 plus 3. Okay, which is equal to 2 times 8. Okay, so these are equivalent expressions. There's 2 different ways to get the same expression, equivalent expression. So having said that, if we look at this one, we could take half of 8, which is 4y, okay, and then half of x, that would be half x, okay, and then we could do half of 12, which is 6. All right, so that would give us the area of this tape measure would be half times 8y plus x plus 12. Okay, but then if we are to distribute it, okay, we would also get the equivalent. The area equals 4y plus half x plus 6. All right, so that's how you do that one right there. So go ahead, copy that in your notes. All right, let's keep it moving and grooving. All right. Whoa, let's not do too much. It says write 2 expression for the area of the big rectangle here. All right, so we kind of did that above, and half of 8y is 4y. Half times x is 1/2 x, and half of 12 is hold up, did I mess up? We already did that. All right, so we were supposed to go down to this one. All right, number 2. All right, so let's keep it moving. We got half times 8y, which is going to be 4y right here, and then half times negative x equals negative 1/2 x, and then half times negative 12 is negative 6, and then we would write that as 4y plus negative half x plus a negative 6. All right, that's what was supposed to happen for that one. Go ahead and copy that down. And then in the next one, it says use the distributive property to write an expression that is equivalent to half times 8y minus x minus 12. Well, that's the same as that. So here, they're just giving you the boxes to help you organize, but it's basically the same thing as here, because you're doing half times 8y, which is 4y, minus half x minus 6, right? And then we know if we add the opposite, we're going to still end up with 4y plus half x plus -6. Okay, so basically they're showing you how to organize it with the boxes, and then they're transitioning you into doing the same thing without the boxes. I think that's the idea of that. So go ahead and pause for a sec and copy this in your notes. All right, let's keep it moving and grooving. All right, so delete that. We're gonna scroll down to the next one and see what they got. Change in average. All right. Let's look at the numbers. Okay. All right. Let me try to shrink this down just a little bit. All right. So it's saying here something like, here's a calendar. Let's choose a date. They chose the 10th. Look at the numbers above, below, and to either side of the 10th. All right. So we got above, below, and to both sides of the 10th. Average these numbers. Okay. We got 3. What's that? 17. And then 9. And then this is going to be plus. This is going to be plus. This is going to be plus 11. And then we would have to divide that by 4. So this is going to be 20. And this is going to be 20. So that's going to be 40 divided by 4. And that's going to be 10. Okay. And that's the same as the 10 here. All right. Okay. Interesting. It says choose a different date that is in a location where it has a date above, below, and to either side. Average those 4 numbers. What did you notice? All right. My birthday is on September the 20th, but this is April, but okay. So we got 13 plus 27 plus 19 plus 21. Divide that by 4. 10, that's going to be 40. Plus 9, 10, that's 40. That's 80. 40 plus 40, 80. Divide that by 4 equals, we get that same 20th again. Okay. All right. I did that so fast. You could do it with a different number and see what you get. All right. It says explain why the same thing will happen for any date that's in a location where there has to be a date above and below either side. Okay, so I'm gonna pause it right there while you do question 1 and 2, and then I'm gonna have to move up the page. So I'm gonna pause. All right, let's delete this. And do we have any room? All right, we got a little bit of room. It says explain why the same thing will happen for any date in a location where there has a date above, below, and to either side. Okay, so say if 10 is like the date, so we pick a date that's like X, any date, and then if we pick the number above it, that's basically X minus 7 days, right? And then if we pick the date below it, that's basically X what? Plus 7 days. So that's going to cancel out. The minus x and the plus x is going to cancel out. You can figure out what's happened now. So if you pick the one up front, the next day is going to be the date plus 1, and the date behind it is the date minus 1, and the plus 1 and the minus 1 cancel out. So you basically left with 4x, and then if you divide that by the 4 days that you picked, you're going to be left with, divide this by 4. Okay, that's all going to cancel out, and you're going to be left with x, okay, which is whatever date you picked at the beginning. All right, so that's about how that would work. All right. All right, so that's a cool little algebra trick. All right, let's keep it moving. Goes to the summary. All right, so it says here, lesson, let's see what we got here. All right, lesson 18 summary. Working with subtraction and sign numbers can sometimes get tricky. We can apply what we know about the relationship between addition and subtraction. That subtracting a number gives the same results as adding its opposite to do our work with expressions. Then we make use of the properties of addition that allow us to add and group in any order. This can make calculations simpler. For example, 5/8 minus what we got here, 5/8 minus 2 and 1/3 minus 1/8. All right, so we can switch this to adding the opposite here and the same thing over here. Okay, so we're going from subtraction to adding the opposite, and now that we have all have gone from subtraction to addition, we can use the commutative property to rearrange the numbers. All right, and that's advantageous because now we got the 8's lined up. 5 plus a -1 gives us a 4, and that makes it easier for us to solve the problem. We still got to do the rest of the problem, and you can do that on your own time. It says that we can also, all right, let me see, going down. Says we can also organize the work of multiplying sign numbers in expressions. The product 3/2 times the quantity 6y minus 2x minus 8 can be found by drawing a rectangle with the first factor 3/2 on one side and the 3 terms inside the parentheses on the other side. Can be found by drawing a rectangle with the first factor 3/2. Okay, so they put the 3/2 here on one side and the 3 terms inside the parentheses on the other side. So they're talking about 3/2 on one side and then the factors on the other. So basically they're saying you can draw your own box to help you organize it. And then it says you multiply 3/2 by each term across the top. Okay, so they're saying you can use this strategy to help you organize your problems, resembling the parts to get the expanded version of the original problem. Okay, reassemble the parts to get the expanded version of the original problem. All right. All right, so that's it for the first part. Now you go on and do the practice problems on your own. If you got any questions, ask me in class. Other than that, peace.